Okay, let's unpack this. Today we're doing a deep dive into the engineering behind commercial audio. We're using the specs for the QSC AD-S112 subwoofer from HDTVSupply as our guide.
Right. And our mission here is really to figure out how these commercial spaces get that massive sound, while keeping the speakers hidden in plain sight.
Exactly, because imagine you are walking into a bustling casino or like a massive transit terminal. You feel this deep, rich bass thumping in your chest, but looking around, there's no giant speaker box in the corner. It's just, well, gone.
Yeah, that invisible audio is a staple of modern commercial design now, and pulling it off requires some very specific acoustic engineering. We're looking at exactly how a relatively compact 12-inch unit creates that illusion.
Right, without compromising on sheer output.
Exactly.
So to understand how this thing stays invisible but hits so hard, we have to look at the engine, and the specs here are heavy,
Oh, definitely. I mean, we're talking 300 watts of RMS power handling.
which is basically its continuous cruising speed, right?
Yeah, exactly. And it's designed to be paired with a 600-watt amp for those sudden dynamic spikes. Plus, it reaches all the way down to 30 hertz. But the stat that really stands out is the 121 decibel peak maximum SPL.
Wait, 121 decibels, that's literally rock concert territory?
It is. It's a tremendous amount of acoustic energy for an indoor space.
Okay, but here's my issue. Usually when you force a small 12-inch box to push that much air, it sounds terrible. You get that muddy, rattling noise. How are they avoiding that physics problem?
Well, what's fascinating here is how they solve it with what QSC calls a TFR, or turbulent flow reduction port. In a standard subwoofer, forcing high-velocity air out of a port creates turbulence.
Right. It literally sounds like the speaker is gasping for breath or something.
Yeah, that's an acoustic artifact called chuffing.
Ah, so if a standard port is like, say, putting your thumb over a running garden hose where the water sprays chaotically and hisses loudly, the TFR port is more like a precisely machined nozzle, keeping the flow totally smooth.
That is a great way to picture it. The TFR design specifically tunes the enclosure's resonance for high-velocity airflow. By eliminating the turbulence at the exit point, you get those extremely high output pressures.
But the bass remains completely clean.
Exactly. Completely clean and precise.
Okay, wow. So it pushes a ton of air cleanly. But surviving in unpredictable environments, like a dusty retail store or a humid outdoor patio, that's a totally different engineering challenge.
It really is. The specs actually mention a rugged ABS enclosure, a powder-coated aluminum grill, and an IP54 rating.
Meaning it's highly resistant to dust and splashes. But here's where it gets really interesting. I saw it uses a paper cone woofer. Paper. For a $1,000 unit meant to sit outside.
Yeah, I know.
That seems completely counterintuitive.
It does sound like a vulnerability, but it's a heavily weather-treated paper. Acoustically, paper is brilliant because it's both lightweight and incredibly rigid.
Oh, giving you very fast, highly responsive bass.
You got it. And the chemical weather treatment seals the fibers so they don't absorb ambient humidity and just, turn to mush. It preserves that premium sound quality in harsh conditions.
I see. And it looks like they apply that same lockdown logic to the wiring. Instead of standard consumer plugs that can easily get yanked out or corrode over time, it uses this 4-pole Euroblock connector.
Exactly. Euroblock connectors lock the bare speaker wires down with actual screws. That is crucial for permanent commercial installs where you simply cannot afford a loose connection.
Yeah, that makes sense.
Plus, on this unit, that entire connector assembly sits under a sealed input cover to block moisture. If we connect this to the bigger picture, commercial spaces demand that kind of absolute reliability.
Right.
Which is exactly why QSC backs it with a 6-year warranty when registered.
Right. All that weatherproofing is great, but mounting a massive vibrating box that hits 121 decibels onto a wall introduces a totally new problem. How does it not shake the building apart?
Well, that comes down to the included yoke mount assembly. It mechanically isolates the unit to prevent vibration transmission into the structure, but the mount also takes advantage of an acoustic principle called boundary plane coupling.
Oh, let me guess. Because low-frequency bass waves are omnidirectional, right? Meaning they travel in a sphere, not just straight forward. So mounting the sub at a specific calculated distance from a hard wall means the waves bouncing backward actually merge perfectly with the waves moving forward.
You nailed it. The sound waves literally stack on top of each other in phase. You are effectively getting free acoustic amplification just by coupling the speaker to the architecture correctly.
So what does this all mean? It means the next time you feel that deep bass washing over you in a public space, you aren't just hearing a hidden speaker.
No, you are experiencing some serious, highly engineered acoustic science perfectly integrated into the room itself.
Which leaves me with this thought for you to ponder. If commercial audio tech has become this weather-resistant and powerful while practically vanishing into the architecture, how long until our own home audio systems are built directly into the literal walls and patios of our houses?
That's pretty wild to think about.
It really is. Imagine feeling that rock concert bass in your own living room without ever seeing a single speaker box.